application of technologies. We work with professors and kind of talk about some feedback on the curriculum, helping students connect with alumni so that they're aware that there are opportunities outside of, once they finish with the university still has opportunities for them, as well as making students and alumni aware of career opportunities. Some of the events, just to quickly highlight some of the events that we've done. Our first event was a cloud presentation with and I'm going to forget his name. Brian, do you remember his name? Jeff Barr from Amazon. He came and presented what Amazon has done in the cloud solution in their space. Our next presentation was actually a roundtable similar to this, where we discussed government agility and how to transition government to the cloud. Then our most recent event was a lunch with Dr. Halal discussing emerging technology. So it's been pretty exciting. We've learned a lot of stuff, and hopefully we'll learn even more this evening. So this is a quick slide about, we'll introduce the board members, and this is a quick slide about me. Went to GW and basically worked in the technology area around DC in the public sector for a while. I'll go ahead and introduce Toby Pratt, who's our secretary, and she's standing right over there. You can read that. I can kind of try to trip over myself, but she really helps keeps us organized and has been contributing so much to helping this board through everything. And then we also have Annette Thompson, who is standing over there, and she's actually going to come up here and talk about ways to connect with us, as well as some of the things that we're doing on the social media space to help reach out to other alumni. So, Annette?
Thanks, Robert. Good evening, everyone. My name is Annette Thompson, and I am the social media chair for the GW Tech Alumni Group. And in that role, I'm looking to, we've established an online community over the last year or so, but we're looking to continue to grow and to cultivate that. So I would ask all of you to share news articles or events, things, networking opportunities, lifelong learning opportunities that might be of interest to GW alumni who have common interests in technology. And I think that's it. This evening we're doing a live video stream. Thank you very much to the GW External Relations Department for helping to facilitate that. And we'll hopefully have this presentation online afterwards for people to take advantage of. Right.
Thanks, Annette. So one person who I didn't introduce who's the president of our board is Brian Moran. He kind of helped pull all this together, get the board started, and he'll actually be moderating tonight. So I wanted to, before we get started, just introduce all of our board panels. So I'm going to step so I'm not in front of everyone. But I'll start off with Brian. And Brian is the country's leading strategist in government IT. As a former federal IT executive, author, respected thought leader, and commentator, Brian is often quoted in government technology periodicals and frequently serves as a featured speaker at government IT conferences and workshops. At GovernmentCIO, Brian leads a portfolio of services dedicated to confronting the challenges faced by public sector IT leaders. As an early adapter and early stage leader in cloud computing, Brian has helped clients evaluate and strategically move systems to the cloud. Brian has almost 2 decades of combined private sector and public sector IT management experience, ranging from software engineer to senior public sector IT manager. Brian holds a Bachelor's of Science degree in business with honors from Towson University and received his Master's of Science in Information Systems with honors from the George Washington University. So I'm going to skip around because I don't think my sheet's in the order that everyone's sitting. But the next I have is Professor Huang. He's assistant professor at the Computer Engineering Department of Electrical and Computer Engineering at the George Washington University. His research interests are data-intensive computing, file and storage systems, computer and systems architecture, operating systems, grid and cloud computing. His research has been supported by grants from the National Science of Foundation, IBM, and GW Institute of Biomedical Engineering. Dr. Huang won IBM Real-Time Innovation Faculty Award in 2008, and his research project, Amdahl Blades, is a high-performance storage challenge finalist at the Supercomputing 2009. Dr. Huang received his PhD in computer science from the University of Virginia, and he is a senior member of the IEEE and a member of ACM. So then moving to the other table, we have Sri Vasrati, who's a federal solutions architect from Amazon Web Services. Sri is a federal solutions architect. He helps federal agencies develop strategies to increase the efficiencies and effectiveness of their mission by adopting secure cloud computing solutions. Prior to joining Amazon, Sri was a principal and group manager for infrastructure operations management practice at the MITRE Corporation. He advised several federal agencies in establishing business strategy and rules to provide scalable, secure, and reliable IT infrastructure and operations management environment. His efforts include the GSA Infrastructure as a Service, RFQ, CMS Data Center Modernization, and DISA NetCentric Enterprise Services. Sri has an MBA from Duke University and an MS in Computer Science from George Mason University. These guys have done a lot. So sitting next to him is R.H. Powell, who coincidentally is my boss. And R.H. has over 15 years of experience leading and managing systems integration efforts for public and private sector customers. His current role, R.H. fulfills two primary responsibilities. Firstly, he is responsible for the successful solution design, implementation, support, and overall customer satisfaction over 100 Akamai public sector customers across civilian, DoD, and DHS agencies. In short, he is tasked with creating customers who enthusiastically recommend Akamai. Secondly, RH heads Akamai's Global Services and Support Security Center of Excellence, which is responsible for incubating security innovation within Akamai services and assists with security product development and the rollout of new Akamai security projects. And still at that table, we also have Bill Perlowitz, the Vice President of Advanced Technology at Apptis. Bill brings over 25 years of dynamic technical and management leadership in support of federal departments and agencies. He possesses outstanding strategic and tactical skills, extensive expertise in developing and deliver service offerings that align technology with mission-critical objectives. He is adept at enterprise transformation, integration by using patterns, cloud computing, virtualization, web services, service-oriented architecture, and enterprise service bus. Bill is a resourceful problem solver with demonstrated talent for quickly identifying and resolving complex challenges, a visionary who is a catalyst for organic growth within the Apptis organization. He's an exceptional mentor and excels at staff development. Bill is chairman of Tech America's Committee on Public Sector Cloud Computing, which focuses on standards development, certification and accreditation, and government-wide adoption of cloud computing services. Prior to joining Apptis, he was CTO of Reliable Integration Services and had worked for United Technology, Sikorsky Aircraft, and IBM's Federal Sector Division. Bill has a bachelor's degree in electrical engineering, administration and management science, and in economics from Carnegie Mellon University. And last but not least is Greg Elin. Greg Elin is a web and data application developer working at the intersection of massively distributed data and user experience. He lives in the Washington, D.C. and Vermont. Most recently, he was the chief evangelist for the Sunlight Foundation, where he was routinely quoted in the media about technology and transparency. He created the Sunlight Labs in 2006, where he implemented and promoted web service APIs for data. He also created Footnotes, an open-source web-based image annotation tool that has been widely adopted. And he is now the chief data officer at the FCC. And we welcome everyone here. So I'll hand it off to Brian to get us started.
Thanks, Robert. I appreciate it. And thank everybody who's here. I want to mention some of the VIPs that are here. Bhavesh, he is, stand up for a second. He's the president of the Cloud Security Alliance, the DC chapter. So if you've actually met him through LinkedIn, possibly, he is the person who's running that group. So if you want to talk to him a little bit more about it.
And we welcome you all. It's free to join. And since I'm assuming you're here, you're interested in cloud computing. So join us in securing the cloud.
Kelly Meir. Kelly Meir is a senior director, and he is the principal of the infrastructure practice for Deloitte. Did I get that right, Kelly?
Close enough.
Close enough. Okay. Let's see who else is here. Oh, one of my former colleagues, Joel Muller at the U.S. International Trade Commission. I just did that just to embarrass him. We have our CFO of our group, who is also a member of the Veterans Administration, Kevin Ruffley. Eric Lasama, he is a program manager at the Department of Veteran Affairs. So I said that just so you guys understand. We have Fred Schindler, who is the Director of Collections Policy for the IRS. So he's the guy who comes in and yanks your money away. And he loves doing it, too. So he has no shame in doing that, too. I can guarantee that. We have Tony Fernandez, the president of Tucson Technologies. We also have, I'm sorry, Toby, I can't remember your dad's name. Alan. Alan, would you like to stand for a second? Alan Ken. Alan Pinn, who's the president of Quotient Consulting. We also have a number of other folks who I don't want to say. Oh, wait, here we go. We have a person who just walked in late who is a program manager over all modernization programs at Patent and Trademark Office for trademarks. We also have Chuck Piercy, who's the deputy CIO at the National Archives and Record Administration. So we have a number of excellent, well-esteemed guests. And we also have one of my former classmates who I'll say is a VIP, Ernesto Campos, who is also Ernie, he goes by as well. And Malia Haddad, who is actually probably the reason why half the people come here, because she tends to have a pretty strong following. Whenever she sends out an email, everybody tends to listen to her and come. So probably half of you guys are here. So before I kick off, Lily's going to hand out a couple of things. She's also going to be the person who's going to raffle the iPad, too. So everybody here now has a chance to get an iPad, too. That includes the people on the panel because you guys didn't even know we were going to do that. So everybody here has a chance. You just have to put your name and your email address on the flyer, on this little card. So she's going to walk around and hand that to you and hand out some other literature and some self-promoting GovernmentCIO stuff that hopefully you'll read and absorb. All right. So the first thing that we're going to do is I'm just going to give a baseline, because I know there's people here that are fairly familiar with cloud computing, and then there's other people here that have never even heard of what cloud computing is. So I'm going to try to set a little baseline here. So what is cloud computing? It's not a buzzword. Cloud computing is a real thing. Cloud computing, it's where you go for technology when you need it, only when you need it, and as you need it. Oh, I forgot to mention, if anybody has their phones not set on vibrate, please do so now. And I'm actually going to do the same thing because I just got a new phone, and you never know if it actually is set right. The next thing, simply defining defining characteristics of the web. It's available over the web. No capital investment required. You pay as you go, and it should be something that requires really no substantial upfront investment. When we talk about the words private cloud, public cloud, I start to get a little hesitant to say things are private cloud. I don't know what the rest of the panels are. That's one of the questions that we're going to talk about. This right here is what we call the SPI model. This is the various versions of cloud computing. We have software as a service, platform as a service, and infrastructure as a service. One of the things you'll realize as you move up the levels of abstraction, infrastructure as a service is the very lowest level. This is where folks like Amazon give you a virtual machine. You apply your operating system to it. You configure it. You do all the patching, etc. You're in charge of everything from the application up. They deal with the bare metal. They deal with the network connections, etc. Platform as a service. This starts to move to the realm of being like an access developer who can deploy their code in a very simple, elegant format. Software as a service, everybody here has used Gmail. Gmail is one of the biggest software as a service providers. One of the things when it comes to security, though, we see some major changes. As the level of abstraction goes up, the flexibility and control you have in a secure environment starts to degrade. And you transfer control, and actually I don't mean the security itself degrades, but the control that you have as a customer degrades. So you have very little influence when you move up to the software as a service over the security controls that are implemented at the vendor level. When you go down to infrastructure as a service, you have a great deal of control. So when we talk about software as a service, it's simply something that you're using over the web. You log in with your browser. You use it. Tools like Gmail, Salesforce.com, Basecamp HQ, QuickBooks Online, tax season. Fred was taking your money. Many of you guys were out there using QuickBooks or Quicken or some other solution. They have many web-based tools out there. You were using software as a service. It's an on-demand utility. Payment terms are based strictly on usage, whether that usage is on a monthly basis or on the spot usage. Minimal IT demands. So your internal on-premise IT group has very little demand associated with the work in securing those systems and the work in terms of maintaining those systems. The big benefits of software as a service: very quick, rapid rollouts. Things roll out very quickly. The vendor can release upgrades and improvements and enhancements over time, and you have very little disturbance to your internal IT. Very low service fees. Typically, software as a service have low service fees. They're based on volume and scale. Quick access to new functionality. As new functionality is rolled out, it promulgates throughout the entire user community at once. And security is all depending upon the vendor. Platform as a service. Typically the tools are accessed by a browser. Some tools aren't always accessed by a browser, but usually it is. Applications are deployed without the need for system administration. So what happens in the past, your Java developers tended to be guys who had to do things like system administration and basic configuration. Well, when you have a tool that's platform as a service, like Azure and Microsoft, they write the code, they deploy the code. They are able to enjoy a streamlined process where they don't have to actually go through a lot of the rigmarole that it takes to instantiate a new server. Some of the benefits: it lowers the barriers to implementation. The other thing it does is it starts to get the developers away from doing some of the scut work that they used to have to do. They can focus more on solving problems and writing code to solve the problems. Some of the other things, the folks who are in the world of creating access databases and Lotus Notes databases, they can start to migrate to the world of the web, and they can deploy applications a little bit quicker. There's a host of platform as a service providers. The list would run on well beyond that. But one of the things in the secure environment, and we'll end up talking about a little bit later, is as you start to move up the levels of abstraction, your internal control that you can exert over the security for the platform starts to degrade. So infrastructure as a service. I'm sure Shree's going to have a lot to talk about this, but I'll just give you some basic high level about infrastructure as a service. It's a provisioning model that an organization uses to create new servers, new equipment, etc. It includes storage, hardware, load balancers, you name it. It's a pay-per-use. There are lots of models out there, various formats. You can either pay for a block of servers, you can pay for each server that you acquire and you provision. One of the main things, though, that this does, and in my article that Lily's passing out that you'll see, this is where cloud computing is not so much a technology, but it really is a business model. It's an economic model. Things have changed because we've moved from the world of spend a lot of money, go out there, buy a bunch of servers, buy for maximum utilization. You got 100 servers because you need 100 servers one time out of the year. Now you only need one server, and then you start to scale and burst out. And I'm guessing Sri and maybe Bill may talk about some of those other things. Some of the things that you have, the benefits, you start to move towards utility computing rather than big capital expenditures. You have access to massive data centers. So no longer are you constrained to the small data center for which you manage. You have access to very large-scale, broad data centers. And that's it. I'm going to start talking about the governance model for security. So we talked about the different levels of abstraction: infrastructure as a service, platform as a service, and software as a service. When we're talking about infrastructure as a service, the organization, the customer, has control over the application, and you share control over the VM. So you can instantiate VMs. There are usually predefined VMs that you can create. You can create images for those VMs or templates, and you can instantiate them. The server itself, the storage, the network, all of those things are being managed and controlled by the organization, that the cloud service provider. A platform as a service, this you actually share control at the two highest levels in the application and the services. Everything else remains at the control of the cloud service provider. So that means if you have a need for doing audit logs, you have to create those audit logs in your application, and you might not have access to those audit logs upon request of the service provider. That's one of the major risks, in moving to platform as a service that some of the people feel. Software as a service, there all control is on a provider side. So the maintenance and the administration of the system, the maintenance of the application, the maintenance of the services, storage, network, all of that is done over at the cloud service provider. Customer security controls. I'm actually not going to bore you with this stuff. I included it here because I thought it would be fun to geek out a little bit, but I'm going to let the panel geek out. So I'm just going to rotate around the room. We're going to start off with Bill, because Greg said to start with Bill. And then we're going to come back around this way.
Great, thanks. Can you hear me now? Okay, great. So just so you understand my bias, I'm a system integrator, so we don't actually have a product, but what we are essentially responsible to do is go in and build and certify and accredit, now authorize and accredit systems for the government. So what I wanted to talk about, rather than the actual mechanics of security, is what is it that we see when we go out. And the important thing to understand about cloud computing from my perspective is it is not a technology. Cloud computing is a series of capabilities that you buy. And in the world I live in, those capabilities are defined by the National Institute of Standards and Technology in a special publication that they call 800-125, and it tells us that there are 5 essential things that you have to do to have a cloud computing strategy. So the first one of those is on-demand self-service, meaning that I must be able to provision these things unilaterally without interception by a third party. So it's not something I would do on a phone call. Generally, there's some portal that I would access these services by. The second thing is broad network access, meaning the resources are accessed over some type of network. That may be the internet. It's not necessarily the internet, but it is accessed remotely. The third thing is resource pooling, and this gets into the concept that these resources are shared with others. And I imagine there's going to be a great deal of discussion today about what the implications of that are. But I have a pool of resources, and I access those when I need them, and I release them when I don't need them anymore. That's called elasticity. And elasticity must be rapid to have cloud. And GSA has defined elasticity as 1,000 times the base. So if I were going to allocate a virtual machine in the cloud, in order to be elastic, there should be at least 1,000 of those available to me. If I'm going to allocate 1 gigabyte of memory, there should be at least a terabyte available to me. And the last thing is measured service. So in the commercial side, we're actually charging for these services. In industry or in government, there needs to be some type of chargeback mechanism. If that doesn't exist, then what I'll do is allocate resources and never release them. And that would kind of defeat the purpose of having utility computing. So once you understand that I'm not actually buying technology, when you start to discuss the adoption of cloud computing with people, the first thing you need to come to understand is you're not making a technology decision. So you're making a business decision, and in lots of cases you are making a risk-based decision, which is what we're here to talk about today. And the first thing that happens when you have a risk-based decision and something's new is you see security as a defense. So you will hear the cloud is not secure, and hopefully today we're here to kind of dispel that rumor. There are many more difficult problems in cloud than security. Transnational data flow, international law, data sovereignty, who actually owns it when it's not physically in my presence? When can the government come and take my data? These, in my mind, are much more difficult issues, but we'll talk about security today. And the next thing that happens is once I label something cloud, I immediately jump from the concept of having a risk-based security requirement to requiring perfection. So what you need to think about when you're actually thinking about adopting cloud is, how good is my security now? And can I get security at least that good in the cloud environment? There's no such thing as perfect security. I don't think anybody here would say that their solution is perfect or could be made perfect in the environment that we have. And the next thing that happens is you see that we have people using the same services, the same infrastructure, platforms, and software over and over again. So what this allows me to do is, if we can agree on what security controls need to be implemented, we can do them once. Right? I can go to an Amazon and I can say, okay, I as the government want these 165 odd security controls. I think it's 215. And these are going to be enough for what we call FISMA moderate. Do those one time, and instead of spending an average of $180,000 on every application that we need to certify, we can do that one time and save 80% of the cost. That program is called FedRAMP, which is the Federal Risk and Authorization Management Program. We'll be happy to talk about that later. And the last thing I would say is, just because you're buying cloud services does not mean you shift the responsibility for security from your agency or yourself to the cloud provider. Even if they claim to have some level of security within the infrastructure, within the platform, within the software, the ultimate responsibility for that security is yours, and you should trust but verify, and in all cases, ask for evidence. So with that, I'll turn it over to Shri.
Thank you, Bill. All right. My name is Shri Vasireddy. I'm from Amazon Web Services. So at Amazon Web Services, we like to look at cloud computing not just from the perspective of different delivery models and deployment models that we talked about, but from a web services model, as our name says. Right? It's Amazon Web Services and not just simply a low-cost hosting model. Right? What I mean by that is, we hear a lot of buzz about, hey, SOA was buzz once, and now it's the cloud, right? But there are very few companies, Amazon included, that were really successful in implementing SOA, right? The service-oriented architecture, the trouble with really implementing service-oriented architecture at scale is that underlying service-oriented infrastructure that can be as agile as the software that is on top of it, right? That agility in the infrastructure did not exist. And that's why the service-oriented architecture implementations ran into trouble. We, at Amazon, figured it out really quickly. In the beginning, we understood what our competitive advantage was, and we said, how can we make the infrastructure as agile as the soft application? So literally, the reason it is Amazon Web Services is because whether it is storage, compute, anything we provide is an API call away. So you could write code that says, get data center, get server, get storage, run this server, and run this service, and you're up and running a website in minutes, right? So that SOA on service-oriented infrastructure leads to service-oriented operations, which is what we're all about. I mean, service, SaaS, PaaS, it's all about service-oriented operation, and that's cloud, right? So if you look at it in those terms, and if you can look at how can I really get to security, not from that boundary model that we are used to, but from securing information, right? And by securing information, I mean in our, to take an example, in our simple storage service, we have about 220 plus odd billion objects, and objects are like files and video files, pictures. For each object, you can create a policy that says, if so-and-so is coming in from so-and-so location, IP address, and their email is so-and-so, and they have so account number, give them read access. You can really create policies at that scale, right? And I can have an ongoing discussion on and on about how much security there is, but I don't think I'm ever going to be able to convince anyone on security. It's me like telling, I'm a daycare provider. I'm trying to tell you that I have a master's in psychology and childcare. I have I have a nurse practitioner. I have EPR. Leave your kid with me. You'll be great, right? Yeah, it's not going to happen. That's not going to happen. What it takes is for you to leave the kid for an hour, 2 hours a day to a point where you leave and go for a vacation, right? So that's why we say come in, try it yourself. I mean, check out the security yourself, and you will know how much there is, right? And I'm not going to be able to convince anyone because I've had discussions for more than 2-3 hours ongoing, and I probably answered every question they had. It's not about not about security. It's about trust. And that's the same thing, as Bill mentioned, it's with every technology. We're so used to AT&Ts and Verizons of the world carrying our voice traffic, but when the data traffic came out, we were all afraid of putting data in their hands. They're carrying your voice. They're only going to carry your data now, but still we're afraid, right? It's very natural to be afraid of the unknown, right? So all I suggest is, try it out. Don't cost you much. And the Netflix CIO, when he said, and Netflix is the biggest, not biggest, he's a large customer of ours. And when we asked the CIO why he picked Amazon Web Services, he said, because I can just get out of it whenever I want. No commitments, no contracts, no lock-ins. We're all about customer obsession, right from Bezos down, is serve your customer, focus on the customer, not on the competition. So.
Am I on? Yep. Well, I did have a 2.5-hour presentation for you guys, but I was not given that full amount of time, so I had to shorten down to really 4 points. So, one, I wanted to let you guys know what Akamai is in the 30-second version. What is at risk when you need to think about security and the cloud? I have a point to make that size matters, and things to consider. So what is Akamai? Akamai is a massively distributed computing platform. We, in some ways, were really cloud before cloud was cool, because we were delivering these services, and we hit on what FISMA and NIST had already defined, or what is now later defined as cloud, years and years ago. But our point is we want to make the internet faster. Today we do that. You use us every day if you use internet, and I suspect that everybody in this room uses internet on a daily basis. We serve about 16 million requests per second. It's a little bit over 1.4 trillion per day, and about 20% of World Wide Web traffic goes across the Akamai platform. So we have an interesting perspective being distributed around the globe on what's actually happening in the cloud. So what is at risk? The same things that have always been at risk. A customer's reputation and brand is still at risk. There are dollars in revenue at risk. Even for government customers, there are dollars in revenue at risk. And most importantly, customer trust is at risk. When you leveraging the cloud as a way to protect that trust and to scale over time, I have lots and lots of stories that I suppose afterwards, if people want to hear, that I would have given you in the 2.5-hour presentation, but in this one I'm not. And the key is sometimes you only have one chance to make the bad choice and to make the wrong decision, and hopefully you want to be good enough in your security governance and your security programs to avoid those really, really big, earth-shattering corporate taking down sorts of mistakes. So size matters, especially when you're thinking about deploying in the cloud, and making sure that you have a very elastic platform at your fingertips is critical. It's critical to making sure that when something bad happens or something good happens, when you're talking about these flash crowds that can occur, that you have time to decide how to take that out to the public, right? You don't want the public coming to you and saying, what in the world's going wrong? You guys are not available, right? You're down. We've had customers, the beauty from my perspective, of this massive broadband capability that is propagating around the world is that it also means that with the good comes the bad. And the types of attacks that we have seen against our customers have peaked at over 200 gigabits per second of attack traffic. And if you put that into perspective with something like the trusted internet connection and civilian agencies kind of consolidating down internet connectivity to a smaller set of data centers, the biggest one that I've seen so far has about 14 gigabits per second. So you have hundreds of applications sitting behind a trusted internet connection. Actually, a really small distributed denial of service attack can take that entire data center offline. And you say, well, they'll just fail over to the other data center. Well, the attack is just going to follow them in their failover process to the other data center. So size matters when you're thinking about using the cloud for elasticity, because it could really save your bacon. So what do you need to consider? Bill, I think, hit it absolutely on the head. Accountability still lies with the business owner, right? You can't ship off. You can ship off some responsibility to your cloud provider. You cannot ship off accountability for your security program and your security governance. There are a lot of things that will allow you to actually do security better by using cloud providers. There's a different incentive for commercial providers like Akamai, like Amazon, to make sure that we have the best security in the world. But where we have responsibility, the business owner still has accountability. So defense, the same things that were true before are still true now. Defense in depth matters. You need to layer defenses. Defenses are more than just a network. A network it's more than just your perimeter, right? You need, like Sri was saying, you need to defend the actual information as it's being created, as it is being transacted and manipulated, and as it's being transported across whatever network you're transporting it across. It needs to be defense at every point that something is hit. And you need to maintain visibility and awareness. And if you're picking your cloud providers correctly, you will actually have greater visibility and awareness and control of what you're doing than you've actually had in the past. And the reason is because those cloud providers, again, are incented to provide tools and capabilities that allow you to reach in and have that kind of visibility really, really there at your fingertips. And because if you're looking at somebody like Akamai, people are bad. You want to get rid of people at every step of the process. And whenever you have to have a person involved, it costs money. And businesses are not in the business of spending money. They're in the business of eliminating having to spend money. So when we build these automated tools, it's not only there to help us, it's to help our customers as well, to basically build a really sustainable business model that is secure and takes us to the next step of the internet, really, in that evolution. So that is my 2.5-hour presentation condensed down into hopefully about 5 minutes. There you
go. Okay. So I'm Howie Huang. I'm actually teaching cloud computing at GW here. So today I'm going to talk about my research. In the first part, I'm going to talk about energy challenges in data-intensive computing. That's going to digress a little bit from the main theme here. And the second half, I'm going to talk about security challenges and what my group is doing. Okay. So the data growth, data is really important because now with the social media, with different sensors, instruments, it's very easy to generate data. And data growth is really the largest data center infrastructure challenge. That's why we built these massive data centers. On the top of this, it's not really new data center. I think it's a few years old. Google data center is in Oregon, and it's by a river. And there's a reason they choose this site. And on the bottom is a Microsoft data center built in 2008. It's in Texas, and it's actually 11 football field. And some numbers, and this data center costs $500 million, and they use a lot of nuclear and wind energy. And second, they use 8 million gallons of recycled water, so for cooling. So these numbers are really impressive. And also the government did some estimate, it's EPA, and the numbers like this, the energy used by these data centers, these servers, not counting the personal computers, actually counts towards 1.5% of energy used in the United States. And this number already doubled from 2000 to 2006. And by this year, it's going to double again. So what we are talking about is 3% of U.S. energy consumption goes into these data centers. So we have this power ceiling problem. By that, what I mean is how many machines you can put into this facility. It's not determined by how much cash you have. Trust me, Google, Amazon, Facebook, they have enough cash to buy as many computers they want. But the problem is the power budget, is how much energy you can deliver to this facility. That determines how many machines you can buy. And the power cost is already close to or more than the money you spend on the machines. And when you look at a single computer or these data centers, you have the computational power and you have the I/O power. By I/O, I mean input and output, data access. The computer industry gives you this mismatch because we can always get faster CPU frequency. But on the other hand, the I/O speed doesn't improve very much over the years. So that's why you have this I/O gap, performance gap, between CPU, memory, and storage, disk storage. And one of the projects I'm doing here is called this balanced architecture for data-intensive supercomputing. What we try to do is design an architecture that allow CPU and I/O to meet in the middle to achieve this balanced compute and I/O capacity. And what we try to do is take low-power motherboards, mobile CPUs like you use in laptop or mobile computers, as well as this new energy-efficient solid-state drives, the flash-based devices, to construct a new system that allow you to get reasonable CPU performance as well as the I/O performance, and also save a lot of energy in the meantime. And this project is supported by NSF, high-end computing university research activities. Now I want to quickly go into the second half, the security aspect. And also I'm not talking about traditional security. I'm talking about when you go to Amazon or go to some public cloud, are you really getting the performance that you are paying for? The answer is actually not when you consider interference. By interference, I mean the impacts from other applications running on the same resource. Because you go to the cloud, I'm going to go to the cloud, some other people are also going to go to the cloud. We are going to share the same machines, same network, same storage. And when you are doing a lot of computation, that's going to be okay because we do have good support from virtual machines, from the infrastructure. It's relatively easy to implement a fair sharing policy on CPUs. And it demonstrates the minimum, the impact is very minimum. But when you try to do a lot of data-intensive computing, for example, you try to process a lot of data, then that's what I say, you're going to run into this nightmare. And I have some numbers here. If you do a computation, and on one virtual machine, let's say virtual machine 1, and in the meantime, do another application in a second virtual machine, VM2. And if you're doing CPU intensive application or I/O intensive application, or some medium CPU and I/O activities, or CPU I/O, both intensive applications. And you can see if you are doing CPU computation, that's okay. The slowdown is very minimum compared to the I/O. When you do a lot of I/O, here is doing just sequentially read one big file. So sometimes you can see slowdown by 10% or 16%. okay, you still pay the money to get onto this virtual machine, onto this resource. But it depending on what other people are doing on this machine, you're gonna have a good performance or bad performance. It's really up to the infrastructure. And I can make things worse, okay? I can even identify your I/O patterns and choose and design a tag to attack your application whenever you are doing a lot of I/Os. For example, here I show the runtime. This is time scale, and the green is your normal application. What's your I/O pattern? And here is the red is my attack. What I try to do is whenever I see you doing a lot of I/O, I issue a lot of I/O at the same time. And I make prediction. For example, I predict you in the 3 seconds, you're going to do a lot of I/O again. In 3 seconds, I'm going to do a lot of I/O again. Basically try to steal the resource and the list of your virtual machine and make your application slower. And nothing actually prevents me to doing that. As long as I have a credit card, as long as I'm willing to pay Google or Amazon or any other providers, they will allow me to get to that machine. And once I know you are there too, I can do this attack very easily. And even when there are some other people there, that's what I mean by noise. I can still identify you still exist behind the noise and attack afterwards. Okay? So given this attack, what can we do is something that my group is developing right now is called TRACON. It's borrowed the term from aviation. What that stands for is task and resource allocation control. What we try to do is minimize this interference among concurrent applications, and using the interference-aware prediction and the interference-aware scheduling to help to minimize the interference among different applications. And we did have some preliminary results. It's very promising, and we hope that we can even get better even greater benefit, not only to the users. The users can save money and avoid this kind of attack, and also to the providers, because providers can complete the same amount of job within a short period of time, right? And be able to save some cost on energy as well. And last, I want to thank my sponsors, research sponsors from National Science Foundation and IBM. And I have my email address here. If you have comments or feedback, feel free to contact me. Thank you.
I'm going to. Okay. I'm going to stay seated if that's all right with everyone. Thank you for having me. It's a pleasure to be here. I'm really impressed with everything that I've heard so far. I think that pretty much everything that people have said is correct. I want to first point out the disclaimer that I'm really here as a customer of the cloud, someone that's an agency that's exploring it, and nothing that I say should be interpreted as FCC policy or things like that. I'm here more as a technologist and a consumer of the cloud. I brought one visual to share with everyone. Let me get it out. So this is a draft of our certification for our new the security certification for our new website that you can see at beta.fcc.gov. And it's actually printed on both sides. So I think the first point relative to security in the cloud, or just security in general, is that this is the world that I currently live in as a Govie. That we have to prepare this and produce this, and that to Bill's statement earlier on, the security component is not yet pluggable in the web. Everybody is actually doing their own certification still at every single agency. So as we get towards FedRAMP or some other things like that, but for the time being, this is important that each agency still has to do its own certification. And we've also had the experience with our lawyers where they say that's okay that GSA has cleared that terms of service, but we still have to clear it here at the agency. So there's that sense of having to, that the customer is still the owner and responsible and having to go through the processes. Tied to this, I think one of the experiences that we're having with the cloud is that our security infrastructure is inside of our data center. So we already have a substantial investment with the software that we've purchased to do security, to do monitoring of logs and other things like that. We have an investment in the people that are trained to do that work. We suddenly move to the cloud, our security tools and licenses may not go with us into the cloud. And we actually have figured something out in the configuration we're using where we're piping information back to our existing infrastructure to do the network monitoring. But if you can understand that, one has a security investment within the organization and tool set, and suddenly you say, well, actually my data center, my application's over there. And do you have sufficient bandwidth, or do you need to put equipment in the clouds? And how do you connect that? How do you connect that together? A couple points that I wanted to hit on, speaking as the customer. I'm not sure if everyone knows it, but within government there are basically 3 categorizations of security. That information is classified by NIST into 3 general categories. That's low, medium, and high risk. Okay, so that's sometimes referred to as FISMA low, FISMA medium, FISMA high, but it's basically classifications determined by NIST. So low means basically there's a low impact if there's a security breach. If someone gets a hold of something, it's not a big deal. High security is that you're basically very screwed, your organization's screwed, there's going to be cover on the New York Times, but there's a big impact at the high level to your business and to your organization. And medium, of course, is somewhere in between. And there's some guidance of how you do it. So in moving to the cloud for ourselves, we decided that we were going to focus on everything that would be considered low. So we're focusing on the website, on stuff that's already public to the community. We're not focusing on information. I mean, if we were going to do our email would suddenly be medium or maybe even high. Because if there was a breach to our email, there could be lots of information inside of that would be problematic. So we started with low. And as I said, just because a given vendor has said that we have done certification at the low level, we still have to do the certification ourselves because it has to match the policies that we have internally and the check marks. And I think that's an important understanding that. I think with respect to kind of data in the cloud, there's an interesting question of locality. I was just thinking of that. What data is next to what other data? So it's really easy when you're behind your own firewall that you can put very valuable or high or information that might be high right next to information that's low. You can have them mixed inside of the same tables. I can have a table that has some personally identifiable information, or PII. So if I have PII sitting inside of a database table, that might only be one column, but essentially that whole table now, or that whole database, is something that I have to treat carefully because of that PII in one column. So the question of the locality, what data is next to something else in the structure of our applications and how we treat services. I think one of the things that does happen, I'm actually just going to pick a little bit of a fight so we have some excitement. I like the definition of technology as embodiment of practice. It's some type of embodiment of practice. So for me, I'm a little bit more liberal when it comes to technology, and I would say that the cloud is a technology because it's a set of practices. As opposed to, I agree its capabilities, but I would also say it is a technology because when you move to the cloud, you have to engage in a certain set of practices which compartmentalizes the different componentizes componentization. If you move to the cloud and you're pulling services from different places, software as a software, service as an architecture, service as operations, I really like that. You have to say, I have to think in components. I have to make sure that my storage is a component, or I have to make sure that my security is a component, so that I can move these things and they're virtual and I can move them around. And I think that that componentization and virtualization enforces a practice of people of creating demarcations between these different components. And so that you have to think about security for each one of those. And I think that that overall tends to lead to greater security, because you've now, rather than just have this big kind of gray mass of information behind one locked door, you have to kind of look at the security of each room inside the castle. So I think it actually drives that. I think that I'm going to stop right there. I think that's pretty good.
Okay, actually, some of the stuff that Greg had just mentioned drives home some points that I'm going to bring back with the earlier set of slides that I had here. Okay. So Greg makes a good point. Our minds can't deal with just the concept of the cloud is this amorphous blob, and there's lots of things. We have to segregate things. We put them in buckets, and the reason why we put them in buckets is so that our minds can wrap around it, so that we can say, here's how we secure this thing. So let's look at infrastructure as a service. When you're the customer, you can manage the VM through fault-tolerant designs. So when we were talking about doing computations across a particular VM, and you're within a particular machine, you can do some detection on what's going on inside that machine, right? Well, you know, that assumes the customer only has one machine. It doesn't assume the customer has scaled across lots and lots of machines. So when people do computational intensive things, they tend to design in a manner that will allow them to scale across multiple machines. So availability management in infrastructure as a service has to do with the way you architect the system in the first place. So if you architect it to be fault tolerant, you actually can mitigate some of the risk that Howie had mentioned. And we can talk about this because I think that's he brought up some really good points. In platform as a service, you don't have that luxury. The thing that you actually have control over is the activity of the application. So you can control what the application does, but you can't control what the infrastructure below that does. So availability is still at the behest of the service provider. Software as a service, like I said before, hands off, it's the provider. Patch management and configuration management. In the past, on on-premise IT, patch management was done inside the operations of the unit. You had people who were using SMS or something like that to deploy patches out to the server farm. Here, you have other tools to be able to manage. There are some ways that you can use SMS and other existing tools to deploy patches out to the cloud, but it ends up being something that's slightly different than what you're used to. And I think that's what Greg talks about when he says we're breaking the paradigm of we know how on-premise IT security is managed. Now we have off-premise, we have this cloud-based environment. We need to change our internal controls. We have people who know how to do this. Those people do not know how to do that. We need to retrain them, we need to get them ready, and we need to get their skills up to move into the cloud. Well, that's why you go to GovernmentCIO.com and you register right now. No, I'm just kidding. Hardening databases, that ends up being something that you have control as a customer, and that's something that you can actually manage and maintain. You can actually determine, should you, in this cloud infrastructure, should you deploy these things that are sensitive but unclassified material if you're in the government space. When it comes to access control management, you can actually manage some aspects of the network if you've set up a virtual private cloud with one of the major vendors. So you can set up a VPN link to a place like Amazon, and you can connect to Amazon. And all the traffic will be routed actually through your firewalls, and through your VPN link, you can control the communication back to the servers that you've instantiated. And I'd like to let Sri talk about that in a little bit. In platform as a service, like I said, there's really little control for network management. But access management, on that side, there are a lot of platforms that allow for SSO integration. The same thing with some of the software as a service vendors. When it comes to security monitoring, when you're talking about network, you're monitoring the virtual interfaces. And the other things that you can do, you can also monitor by the way you've built your application, and you can monitor everything at the OS level up like you've done traditionally inside your data centers in a normal on-premise IT environment. Right now, we're going to take a quick 5-minute break. Everybody can go back, grab a drink, and then we're going to come back, and then we're going to go into the question and answer session.
Yeah. I think. Yeah, tremendous number of boxes. And I think, I mean, some of it is that, we're caught in between the legacy world and the new world. Thank you. Thank you very much. Okay.
Oh, and by the way, make sure you get your card to Lily, and you have to be here to get it, or you will not receive your GovernmentCIO sponsored iPad.
Oh, yeah. Oh, yeah.
I think we all know, but has anyone measured, let's say, Google drops the face, like something like Fukushima happens to Google or something?
I think you could just, I think to some extent when Google email or some of these services are unavailable for an hour, people get very nervous.
I know, but and so I think there's a lot of research or some forethought that needs to go into that as to what would be the impact to civil society if that happens.
I think you're right.
Because it's just, and that's the challenge I have with cloud. I'm an ex-operator, so I'm a convert, right? And now I'm running the Cloud Security Alliance. So for the longest time, I didn't have a Facebook account. I just opened one this week. Seriously, so I opened the Facebook account this week. So I'm a absolute convert, but I'm still trust but verify mindset, right? So I'm still not convinced that we have evaluated all the impacts of cloud. It's still evolving. It's nice. Cost is definitely the biggest thing.
Well, I think that the high-end players, I think the high-end players are paying lots of attention to the power issue. I mean, for a couple of years, the people that have been running the really large data centers have been much more focused on measuring the CPU power ratio as opposed to other things. That's been the real. And I think now Facebook just opened their new data center, and they're kind of not only the data center but the actual hardware is all designed around energy efficiency and other things like that. So people are really. I think that the high-end players are very paying attention to it, but I think that most we don't have the models. Like I don't say in government, we don't have the models to measure what we're doing with that. We don't know what our apps cost, let alone what they cost per watt. We are so far away from figuring out that relationship right now. But
because at that scale, at the Google or Facebook scale, they could save millions or tens of millions or hundreds of millions per year just by designing power efficient the hardware or data center. So they have incentives to do that.
You are also thinking about in-memory computing, because I think that should help with the input-output and stuff like that. If you look at in-memory computing, SAP is doing some of that.
When you do in memory, the memory itself is consuming a lot of energy. The memory, the main memory is on all the time. It's not like CPU. CPU you could scale up and scale down, and you consume different level of energy. But the main memory is constant. It's all the time. So
it might have been a while back.
Memory to do what you said.
Maybe a while back.
That's a lot of money.
You did look familiar.
Yeah, I go to GW, the IT director for school of engineering. That's kind of interesting. I also help them with their PCCM. I'm in the school of engineering.
I don't know. We did Sunlight Foundation events here at GW. So that's quite, that's what it might have been through that. So Jared, you care about, you might have been in
Hello. If you haven't filled out your card for the iPad 2, find Lily. She's somewhere in the back. She has some more cards, but we're going to be reconvening in about 2 minutes. So if you see her, fill out a card and enter into the drawing.
Oh, that's great. I don't need an iPad. I appreciate it. Do you want to enter twice? You can use mine.
I may have even left voicemails on your phone over at Apptis about Amazon Web Services and the apps.gov initiative. I really appreciate what you did. Because that's the battle to fight, is that whenever you want to achieve a new position, no matter what it is, that you have another one of those, you have to fight that same battle where people are going to forget their previous expectations and reset the bar at an unattainable level. We dealt with that with VMware when we rolled VMware.
I've got a great quote from Machiavelli I should send you. That kind of encapsulates that. It's a little long. You're absolutely right. Yeah, for some reason, I mean, security people... It's fear-mongering. Well, yeah, and it's perpetuated by some companies that benefit from that. So there are certain people around the Beltway who own data centers that are going to sell private cloud. Their solution is that's what they throw out. I think, fortunately, within 18 months, I think all that's going to be. And, when we came up with our strategy, we said, if you want us to build your private cloud client, that's not going to be our strategy because that is a short-term, unsustainable.
Well, you don't just keep the same. One of the big benefits of moving into and I wrote a paper on this recently from CIO, was that there are really two components. There's virtualization, and then there's infrastructure as a service. We're going to virtualize it. We're virtualize it. And then we're going to take it out and we're going to buy as a service instead of buying the infrastructure as a block of hardware.
So what we did is
All right, everybody, let's go ahead and start sitting down.
For database?
Well, we have a high-ops cap, right? We work with Sri on this high-ops cap, right? You can only reach a point of diminishing returns where you cannot achieve any more high-ops. And with heavy database like a particular application uses, we're going to be up against that. So we have to think about maybe breaking it out into knowing each chart, having asynchronous writes and things like that.
Yeah, or you can look at the techniques like Oracle's used for Exadata. We have 50% of their processors dedicated to IO. Doing prefetch, well, they're doing table joins.
Sorry? Yes. Well, I mean, I wasn't.
They're actually seeing some interesting 10-to-1 apparent.
It was very.
All right, guys, let's go ahead and have a seat.
More stressful than I realized at the time. Yeah, because it was just like.
Thank you.
There's we have a number. We have like any government agency, we have a number of contracts. So every time you could only fund the contracts for. So if they did a continuing resolution for 3 weeks, then you'd have to fund the contracts for 3 weeks. And then the next 3 weeks, you'd have to fund the contracts again. And we were trying to do a new IT contract at the same time. And so everything was happening simultaneously. And it was just absorbing a lot of attention.
If you have bad security now, you're pleasantly surprised.
You end up losing money, right? Because you guys spend a lot of time and energy to plan for the shutdown, and it didn't happen. Then you have to redo everything again. You know, there's a single lot of time lost in all the agencies.
That's very true.
The productivity, I think, was really low, right, for a couple of weeks.
Yes. So do you really, I mean, I thought your material was really interesting, but do you really think that people would make an attack just to slow someone else's performance down?
Actually, people making an attack steal your keys, right? I mean, but
What do you mean steal your keys?
steal your encryption keys. That people have done and demonstrate can be done in Amazon.
Thank you.
They can do that. They
Wow.
can steal your encryption key, private key, by doing some attack. But what we try to do is, for example, we are competitors, right? And I know you are doing some calculation in Amazon, trying to push out your product. Okay, but I'm behind. I'm behind the development. So what I can do is I can go there and slow down your simulation. So your product release is gonna be slow as well. And I can gain some advantage by doing that. And it costs me very little money. You know, on Amazon, you know, one CPU hour.
All right, here we go. We're going to start kicking it off when our speakers arrive.
Well, I suppose it would be a bigger impact if I'm doing some type of trading or other things like that.
Yeah. And if I know I have some inside information.
Right.
Okay, so Walter, I think you're going to be talking a lot. I can go now.
All right, so now we're going to go into the question and answer session. I'm going to ask a couple of questions of the folks on the panel, and then we're going to give a chance for the folks in the audience to ask questions as well. So my first question is, a lot of you guys probably in economics read The Wealth of Nations. One of the things that Adam Smith talked about in The Wealth of Nations is the concept of specializing in tasks, the division of labor. So when it comes to cloud computing, one of the big advantages to cloud computing is the concept of scalar use of specialized knowledge. So where the providers can actually set up camps within their organization who are highly skilled at tackling very specific problems. So when you run into an internal data center, Jack is the system administrator, the network administrator, he configures the routers, and he does a whole bunch of other things, right? Well, when you run into a cloud environment, you have a whole bunch of folks who are very specialized and understand a lot of specific, unique problems. So, and this is not a softball. So, in terms of security, how does that impact cloud service providers? Shri, you want to kick it off first?
Oh, definitely. You know, when you started the question, for me, that division of labor is about gaining the competitive advantage, right? And we are in the business of dealing with the muck and letting our customers focus on their competitive advantage. So by that I mean, you know, think of decades ago, when there was a beer company that was spending, you know, majority of their time managing a generator, right? Beer company that's supposed to be focusing on the taste of the beer is managing a generator. And when the electricity became a grid, it was very difficult for them to give up that generator, right? Because it was a very critical input, right? But eventually they did, because they trusted in that security. And Thomas Edison's company that was making those generators did not go out of business. They started making light bulbs and washing machines and all that. So, right? So cloud is also about empowering our customers to focus on their mission, innovate in their mission, because the infrastructure, as I said, is disposable, and it allows you to try many ideas because the cost of failure is low, right? There are some metrics floating around that 95% of the startups are, you know, start on Amazon now, right? So it is about really taking Adam Smith's principle and enabling Adam Smith's principle so you can focus on your competitive advantage. I mean, I will say our competitive advantage is maintaining, you know, those large data centers, and there's a metric just to give you, on a daily basis, the amount of capacity that we add, infrastructure capacity that we add, is equal to what Amazon.com had in its 5th year of operation when it was a $3 billion company. So that's the growth that we manage, right? So there's definitely a competitive advantage there, right? But for our business is to get you to your competitive advantage.
I was going to ask, in the federal sector, what is the barrier to adoption of the cloud? I mean, not just in the theory, but in real practice, going from agency to agency.
I'd still say the barrier to adoption is, you know, trust. I mean, I know I'm just getting back to that, but that's why if you start looking at, you know, the other things that I run into usually are, and something that, you know, we're not good at everything. At the end of the day, it is x86-based architecture, right? So if you have, you know, a bulk of mainframes, right? You know, very tightly coupled, large applications, right? That's not a straight move in, right? But if you have applications that are, you know, x86 based, and, you know, if they're, you know, SOA, even better, but literally if it's Windows or Linux based applications, they're much easier to move. Others are, you know, harder to move, and a lot of our agencies do have that part of it. But the biggest barrier in my mind is, you know, is trust, and you know, it's about moving slowly, gaining that trust, and moving the rest of it.
Before I actually ask my next question, I'm just going to talk a little bit about the barriers in government agencies. It's perceptual. I think that's one aspect. The other aspect, Greg had talked about it, it's the concept of we know how to do it one way. In order to do it another way, it's going to take a rethinking. It might not take as much of a rethinking as people perceive, so that perception is still there that drives that concept, but it ends up being a concept that we're not used to doing that. We're not certain about this. We're not comfortable with this cloud because cloud concepts are new. Now, Bill and I were having a conversation on the side before, and we were actually poo-pooing Elin's, Mr. Ellin's description that it's a technology, not a business model. And I'll let Bill talk about
Bring it.
And the concept is it's a business model built upon a set of technologies that deliver a certain set of capabilities. Those technologies have been in existence for quite some time. Some of the uses may be unique and different, but we're seeing an evolution in the uses that's turned into an economic model. Now, that economic model is very different for government agencies as well. That's the other big barrier because government agencies are used to capital investments. The Exhibit 300 process is designed around capital investments. So when you switch to something that is an operational expenditure, we've now changed everything, turned things more into a cell phone bill than in terms of buying boxes when we need a new system. So, Bill, you want to talk about it a little bit?
Yeah, I mean, as far as barriers, a big barrier is acquisition because you're going to a pay-as-you-go model with an undefined price. The government has no idea how to do this. They're not able to commit resources past the first year by law. So that part has been a tremendous challenge. So just providing the vehicles for the government to buy off of. The second one is security accreditation requires you to define a system boundary. So what is in this system and what is not in this system. When I physically move that into a cloud, it becomes very difficult to define where the boundary for my system is, and it requires a new type of thinking for how I'm going to permit security to occur. And I'd say the last piece is the actual physical location of the data. We're now concerned with a couple of things. So the FISMA security requirements actually require the data to reside in U.S. controlled territory and only be accessed by U.S. citizens. If I put my data in a cloud, I could have data centers in Ireland. I could have who knows where it is and who knows who's working on it. So those three things, I think, so far have been the most difficult barriers to acquisition.
Again, those are perception barriers, but because I can answer that all those barriers can be overcome. They have overcome, right, other agencies.
Greg, do you want to just real quickly speak from your perspective within the federal government?
Regarding
the barriers to
acquisition, procurement is period, is the biggest challenge, the biggest time consumer, the hardest thing inside of government. Everything if you do firm fixed price, then the risk is less to the government, but you have to really describe very well what you're doing. If you do time and materials, then it's really easy for things to go. And exactly, the government is, I can't do a procurement beyond a current fiscal year because Congress hasn't authorized the spend. And so the terms of service, all of that stuff, it's very, so just a little side note, we did a cloud procurement. I won't say any details, but we did a cloud procurement, and we thought, and one of our questions in our solicitation was, do you have multiple locations? And they said yes, but we actually didn't purchase multiple locations when we did the acquisition. So they supported multiple locations, but we didn't specify that we wanted our data in multiple locations. So now these things there's just a tremendous amount of details to manage with it, and I think all the different all the points that were being said, that's the biggest challenge around this. And I think there is one situation where, if a government agency had a large cutback, if you already spent the money to buy the hard drives don't get taken away from you. But if you're completely up in the cloud and you're paying as you go, your costs may be less, but suddenly you may not have, it's not clear if you're going to have those funds. And I think that the government is trying to figure that out.
Well, actually, we're going to hold off on a lot of the audience questions until we give a chance for the panel to talk a little bit.
I do want to point out, though, that a book. Sorry. a bookseller decided that they wanted to make a generator. You know, that with in reference to the beer company and the generator, that Amazon was in the business of selling books, and they decided that they were actually in a technology business and that they can make the generator.
He's good.
Yeah. No, but I think, but you know, in some cases, you don't want to be doing that if somebody else can. But I think at the same time, there's always an interesting question of if you control what part of your destiny do you want to control, and you can. And that sometimes you can control that entire stack, which is why I think Amazon decided that they actually could do much better if they had much more control rather than turning it over to the manufacturers and other people. And by doing that, they changed the game for all of us.
RH, it looked like you were positioning.
Yeah. So when you're one of your questions had been how do these requirements impact cloud providers? I think that cloud providers need to be ready to handle this contractually. We need to be ready to support security and security governance models as part of our contractual obligations. We also need to realize that I think the game of security is changing, and where it's well beyond checklists. Good security, at least, is well beyond checklists, and it's about a cultural paradigm shift in the way developers think about developing applications. And I think that's part of the advantage of leveraging cloud-based services is I do see a shift in how developers think that they have these deep scalar expertise that are flavored horizontally across a set of expertise with security as part of the cultural mindset. And if you develop security into it, security is no longer just a checklist and you fill out the documentation for a certification and accreditation or following FISMA guidelines or DITSCAP or whatnot, but you make security an everyday activity and an everyday movement that the organization goes through. It's not just one penetration testing that penetration testing is something that's constantly going on. It's just not one time that you think about how do you protect PII, but when you're designing how you store and process and handle data, you're always thinking about how PII is handled, and that you're asking the question before the security auditor comes in and asks you the question, which I think is really part of that game changer, is really embedding it, that the cloud providers need to be ready to embed security in. And it's nice because we do have a unique incentive that's different than our government customers. We're incented to do this because without this, we don't have a business, right? Not with the government, not with financial institutions, not with healthcare institutions, right? These security is critical to their business. So if we don't take it on as being critical to us, we don't have a business in that area, which is different. So it's not just a regulatory compliance issue; it's a survival of the business issue, which is a real good, and economics has tended to be a really good driver for things in the past, and I think in this case, economics will help drive the need and the constant improvement for security overall.
One of the questions actually that occurred, and it actually runs with one of the questions that I had here during the break, when a system's compromised, if it's in the cloud, and forensics need to be performed, what are cloud providers doing today to allow for this type of forensic? In the past, on-premise IT, there's a false perception that it's free. You could just have one of your guys inside perform the forensic service. It's not. It's a very expensive service on the inside. It takes a lot of time. It costs a lot of resources to be able to do this. But in terms of the cloud service providers, what's being done out in the cloud to support forensic analysis when there is a hack? Anybody wants to grab this, go ahead and grab it.
Well, I guess I can. So just a brief background. The Chief Information Security Office for Amazon Web Services is former FBI, cybercrime. They have been in those shoes, so they know how to handle that very well. And they handle that pretty often, obviously, as you can think, right? There are many companies around. Right? So it's really, I don't want to speak too much for them, but it's giving the inspector what they want, right? As opposed to trying to oppose. And there are some things even from that side of the fence where it's no longer just take away a disk and go with that information, because it's not that easy to get a customer's information off of that, right? But having said that, what we tell all our customers, in spite of all the security controls built in, just encrypt your data. Encrypt your data at rest, encrypt your data in transit, and if you are worried about, some data leaking, there are solutions. That's another thing. I mean, Amazon Web Services is like the iPhone for the enterprise. And it's not about what Amazon provides. It's about, what Microsoft, Oracle, every software vendor out there provides, right, on the platform. In the same sense, SafeNet has provided a solution that extends their hardware security modules into Amazon Cloud. So you can encrypt your disk like you encrypt your laptop. So each time a machine boots up, it asks you for something and it encrypts everything on it. So if your data, if you give someone that data, they still have to come to you because that's a solution tested by 3-letter agencies that's FIPS 140-2 compliant, AES 256, common criteria certified, all the things, all the controls in place, right? So it's really all about giving, I think, you mentioned control in the hands of the customers. All the control is in the hands of the customers. You can really do what you were doing in a traditional data center. There is no, so when we are responding to it, we don't charge for those. Is that what the, yes. So that's the beauty of it. The standardization of the infrastructure, the FISMA moderate controls or the services we have in place, you get that same price whether you get that server in Singapore or Japan, right? It's all baked in terms of that and that too.
So meaning Amazon will do the forensic or somebody will do it?
We won't do the forensic. It's giving the data. That's
it's handing over the data. Jason, you have a question related?
Sri, how do your hypervisor engineers interact with the customer in the case of a breach or some kind of forensic analysis? Can the customers discuss the situation with the hypervisor engineer, the people managing the hypervisor, to get information about the interaction with the virtual machine and the hardware layer?
Let me see if think of us like a.
So what kind of resources can you bring to bear on that interaction? I mean, it's one thing to say, look, encrypt your data and manage it and store it, and yes, we are responsible for it. But when there comes to be a time where maybe there's a side, a side channel attack or something along those lines, how do you expose the resources for that layer of the infrastructure to the customer?
So some of those are discussed in our security paper in depth, and including, how do we make sure that there's fair share allocation of CPUs and memories, and right? It's because most of these experiments are run on publicly available Xen hypervisor, but there's billions of dollars of investment that Amazon put into the Xen hypervisor to tighten security controls like that. That does not allow customers to just interact with each other on the machine, forces interaction back and forth. And coming to your question, it is, when we're going through FISMA controls, right, as a part of the controls is all about change management, access control to our engineers too, right? It's all, controlled through a bastion host. They have to get approval to handle anything, right? And those are the controls that we are audited and we share with when the customers come to a point where they're undergoing certification and accreditation.
No,
it's
but
a shared responsibility model. That
what Jason's asking, I think, is he just wants to know when they have a data request and they say, hey, we want to know, what's the traffic been between this machine and this IP space and this machine and any other machine, what's happened.
We make those logs also available to you on subpoenas. Yeah.
That's sort of an excellent question. And for the folks here that don't understand what TIC is, the federal government is trying to move towards, and they're pretty close, most agencies are close to being on TIC providers. So your ISPs, the internet service providers for each agency, is supposed to be a TIC provider. They're supposed to be a part of this common infrastructure so that DHS can implement certain controls for monitoring attacks across the entire federal government. So,
did you say what TIC stood for?
Oh, no, I didn't say. Would you like to say what TIC stands for?
If I get it correct, Trusted Internet Connection.
So the Trusted Internet Connection comes from a certain set of providers. And what happens in the cloud world, you actually end up, you can have publicly facing applications that are, so you can have a public IP address in the Amazon cloud, which would be an external service, which would be externally accessible, which would not fall within your environment and would not be routed through your internal controls, through your internal firewall, which means you would not be routed through your TIC provider. So does this run in the face of that? Well, from my perspective, not necessarily, because the things that they're trying to protect are primarily your internal network infrastructure and the sensitive information that you have behind it. The things that are being placed out in the public IP space are things like web pages where there is risk. There's risk of loss of reputation, but the sensitivity of the data aren't there. So
I can add one more thing is, again, focusing on the control for the customers. You can set up. We have a service called Virtual Private Cloud, which basically is just private addressing, non-routable addressing in the Amazon space. It has an extension of the customer VPN and an IPsec tunnel overlay on that VPN. Basically extends the customer private networking into Amazon. All the internet traffic in the Amazon cloud is routed through the customer internet, right? So the TIC connection is at the internet gateway is on the customer side. Amazon is only extending the data center over their VPN or IPsec tunnel, and that's the virtual private cloud.
So you can completely route traffic behind your firewall through that connection?
Yeah. You have your DMZ, IDS, NOC, SOC, everything that's going on that connection, you watch it and you control it like the way you do.
Does that answer the question?
I think that it does, but it sort of boxes out a lot of mission critical applications that do contain sensitive data from moving into the cloud.
Yeah, let me just say that the Executive Office of the President, OMB, are aware that this is a critical deficiency, and at the moment they've relaxed the requirements through FISMA moderate for TIC for cloud, but there is no currently viable solution. So agencies like USAID have decided not to use TIC because it interfered materially with their requirements. But there is no solution. There is no good solution. But it is being worked on.
Well, I actually think that, we can have a deeper discussion, but we also have that VPN connection that I'm talking about. We offer something, you call it a private line. It could be a direct line to you, right? And that could be a TIC direct line. There's nothing stopping you from making that connection a TIC direct line, right?
The trade-off you make there is one of reliability, because if you have a quick event and your TIC line is down and you're routing all of your service through your TIC line up through the VPC to your cloud instances. Sure, your cloud is highly available, but no one can use it because your TIC line is down.
But, just like in a normal environment, you should have multiple TIC providers.
Yeah.
And that's just one of the issues. Go ahead, Eric.
Can we go back to barriers for a minute? Can we go back to barriers for a minute?
Barriers.
Can you talk to the mic with the people on TV?
Yeah, we were talking about one thing we didn't touch on is the organizational structure, how it's organized. You have different owners, for instance, the network, and we're talking about fundings. For instance, if I own a certain portion of the network, then I may
have in my budget, certain requirements that I want to implement in it. But the others may not. And we're also talking about boundaries, right? We don't have a true definition for boundaries when it comes to our technology, right? So these are some of the things that we need to work on as far as anything else.
Those are excellent points, because in complex federal environments or in non-federal environments, you have a bureaucratic structure. And when a bureaucratic structure has things segregated and technology segregated just by an organizational chart, not because they're functionally necessary to be divided in that way, sometimes the acquisition hurdle becomes even that much more complicated, because if you want to move something to the cloud, you only own a piece of it and not where it's hosted or where it's not hosted. And trying to disentangle from a hosted infrastructure in a complex matrixed organization can be very time consuming, just because you're trying to navigate the political channels, because you're going to say that box is no longer going to be here, I'm going to move this box somewhere else. And I'm sure everybody up on this panel has run into that in some situation or another. Excellent comment, Eric. Thank you. One of the do you have RH?
So the exciting thing is that we're living in we are privileged enough, in my opinion, to watch a true paradigm shift, similar to and the pace of change of these paradigm shifts, luckily, is increasing. So there's a lot of job security for everybody out there, those who are already in and who aren't yet there in the job market, who are in this room. But it's similar when you're talking about your forensic data question. I think of it as, look at the profession of being a doctor in the early 1800s, right? That doctor performed all of their diagnostics on their own. And really the concept of shifting that diagnostic responsibility out to somebody else was pretty foreign and not something that they would want to do. They had a specialty and they did that. It's similar in some ways to how we have built out our on-premise infrastructure, where everybody has a core set of IT capabilities. You move forward to today, you have a lot of specialties in the medical profession that in some cases don't even require you to be a doctor, whether it's sonography or lab work, some things that do if you're an anesthesiologist. But the point is they're highly specialized, compartmentalized, like the cloud needs to be compartmentalized capabilities. And that has so changed the medical profession that if you go to a doctor today, the concept of not having that network of cloud medical capabilities at their fingertips to perform diagnostics and to help out a patient is terrifying to the doctor. And I think that we're in that same sort of shift now. There are lots of growing pains with that allow us to take advantage of what the cloud is promising and what it's actually already delivering when you pick good providers to actually give you better access to forensic data, better access to knowing that something is going wrong with the platform that you're using than you actually have today. I think Bill mentioned it at the very beginning, saying you need to the watermark should be, are you getting with your cloud capability at least as good as what you have today on your own or better? And you should be able to pick a cloud capability that gives you at least as good, and in most cases it should actually give you better than what you have today. And that actually changes the question to really kind of what would you do if you weren't afraid? And how would you build out?
I just want to make a comment. I'm probably going to sing a different song. What I'm trying to say is cloud is really not one solution for all the applications. For each individual application, for each individual organization, you really have to look at the trade-off of moving your stuff to cloud. Right? For example, for the high-risk data, does it really make sense to move to cloud? Maybe it's better, even from the cost or from the safe security perspective, to keep it in-house. Right? You may save a little bit of money by moving the data to the cloud, but the risk is just way too high. And also, for the traditional high-performance computing, you want, low latency network. Maybe it's still better to build a local cluster or private cloud, so you can do this kind of scientific simulations. And what's for the data-intensive computing, right? If you want to move 100 terabytes of data from East Coast to West Coast, what's the best way to do that? It's not by moving to the cloud. It's by doing FedEx. Okay?
That's true.
So you still really need to look into your application and your organization to see whether cloud makes sense.
Can I?
Yeah. Right. The organizational issue, I think, is a very big one. I don't think that people have thought much about organization when it comes to what does the cloud mean for organization of IT groups or for agencies. I don't think that we've thought about it when it comes to open source. We talk about the benefits of the applications, et cetera, but we're not talking about how that comes back. And I think what I had a chance to look at the Klinger-Cohen Act a while back, which basically established CIOs in all of the federal agencies as responsible for the technology investments. You won't see the word web or internet in that act because it was passed in 1996. So we're still operating under a lot of laws and memos and other things which are years out of date. I have to hand it to OMB right now, Vivek Kundra and Anish Chopra, the 25-point plan and other things that they're doing, where they're really saying, well, everyone's going to take steps to live in this new world. Everyone's going to go to the cloud. Everyone's going to, do a dashboard. We're going to do these different things as a way of kind of getting our toes in the water and learning and beginning to change culture. Oh, yeah.
Well, that's always the question was, or the statement was, we need to define our boundaries in-house before we can go external. And sometimes, the process of moving to the cloud, I think as Greg highlights, it shatters the paradigm within an organization and positively shatters, right? Because a lot of times bureaucratic structures are set up in a very unnatural format. I've worked within the federal government. I've created probably unnatural environments that Jason and Joel are probably working within right now. But what happens in a federal environment or any organization, when you start to realize that there's a positive benefit in moving to something, inertia will break, and you'll start to move things to the lowest cost provider, managing risk, because I think as Greg mentioned and a couple of people had talked about before, it's always a trade-off in risk. Maybe you're not going to move Jack Bauer's information to the Amazon cloud today, but you might be willing to move some other things like the general web pages for your public website, and there's a whole spectrum in between the two.
I'd like to see Jack Bauer make it through my security system.
That's right, yeah.
That's what I...
Yeah, I don't think Jack Bauer has to go through the CNA process.
Yeah, that's right. I need that procurement in the next hour.
One of the questions that I have, when using a cloud provider, one of the things we talked about is the location of the data. The precise location of the data is abstracted away from us as customers. So there are times where we run into a situation where the data have to be removed rapidly from wherever it's been deployed. It could be because classified material was inappropriately dispersed. It could be because confidential material or sensitive but unclassified information ends up getting leaked and published. And you need to make sure that data have been destroyed and no longer reside out there in the cloud. So how do we tackle that issue? Bill, I'll hand it off to you for a second.
Okay, you might not like this answer. Cloud providers are very good at extremely high availability for your data. I think you guys have 16 nines for permanence, 11 nines. Okay. So the way they accomplish that is to replicate the data into multiple locations. So to achieve that, you are at odds immediately with what we call data remnants, which is when my data is gone, is it gone? And we can make it very difficult to get the data back, but I don't think I've seen a case yet where we can actually prove that the data is gone. And it's been that way on the internet for a long time, and I don't think that problem's going to go away. But I'm sure Sri can shed some details on exactly how difficult it is to get the data back. So.
Yeah, so just to answer many things, again, going back to giving control, the way our cloud operates is it's multiple clouds in different regions. Our boundary for data is that region. So if you pick something in the U.S. region, it does not move beyond U.S. East region, right? From a cleansing perspective, we follow the NIST and DoD standards for cleansing, running through the mill when it's when you destroy it, we don't hand it off to someone, we destroy it, and that's all audited, and that's part of our controls. From a customer perspective, I already talked about how you can encrypt it. What we provide from a disk perspective is a block device, and the customers really format those devices before they use it. They can format it after they use it, and you have control over cleaning your data, right? So there are many controls, and even going back to control, I mean, many things that I heard is control, how do we, the boundaries question. We know that in order to exchange information, right, the traditional boundaries, like for example, the 9/11 Commission, said flip your model to locking, share everything and lock down only what you need to, as opposed to lock down everything and share only what you need to, right? So where, custom agencies started trying to do that, and when two applications, or agency A and B, you had to do that, you have to open a firewall port, and that application all of a sudden has access to the entire data center. And so it was a 6 to 9 months ordeal in terms of trying to get that access, because that definition of boundary doesn't fit the model now, that the change in model, right? So that required drawing boundaries, the flexibility of drawing those boundaries wherever you want them. And that's why that firewall concept, you take our EC2 servers, they have their own firewalls. On top of that, you can create security group, you can create application level firewalls, grouping of applications. So it's really all about giving the control to the customer. Even going back to HPCs, I mean, we have a super high bandwidth HPC offering with someone stitched up enough of them, and we ranked among the top 250 supercomputers in the world, right, among the top 500. So there's that much bandwidth. And in terms of data, yes, we provide a service called S3 import-export, which allows you to ship a ton of information to us, and we'll load it up for you, right? So it's all those tools just available at your disposal with full control in your hands to do whatever you want to do.
RH, do you want to comment on the concept of data remnants?
So I think I agree with Bill. My question back is, how do you do it today, right? How do you do it today outside of being in an NSA environment, controlling those, and when you're done with the disk, you shred it and you burn it and you demagnetize it, right? Other than that, you have a lot of challenges. So I think that it needs to be. You need to be very careful about understanding what your actual real requirements are versus in order to accomplish your mission and mitigate the risk of exposure that you have out there. Because when you're in a cloud, you are moving that out. There are going to be times when a disk is going to be stolen, right? And if a machine walks away from a data center that's not sitting behind M16s, even if it was sitting behind M16s, it could still walk away. Mm-hmm. How have you protected that data, right? Is it sufficient? Do you have the right sort of encryption to make it painful enough to get the data off of that disk, and is that acceptable? You still need to answer those same questions in a cloud environment. But cloud providers like Amazon, like Akamai, have a lot of capability to go and purge that content. And as long as the funding is there, we can support whatever you really want. If you want to actually take those disks and be able to shred them, that's something that we can support. It's going to cost more, right? Because it costs more for us to be able to do that, and we're going to pass that on. But if that's what you really need for your mission, it can be supported. So I think that the question is are you going to be open to alternative methods that may be perfectly fine enough for the mission and appropriate for the mission and the sensitivity of the data, and that's where you're going to be able to leverage the cost efficiencies of shared infrastructure.
So I guess I'm going to toss in here a little bit. in my mind, there's a big difference between running an application that I'm already running on a data center or in the clouds, and the ability to do innovation. So when it comes to the former one, we're talking about applications that the government is already doing, probably have a mission critical nature to it, and have a requirement for stability. And in those, whether we're talking about email, we're talking about licensing that the FCC does. So in those type of applications which are already up and running, you're going to look to the cloud and say, does this provide me a cost incentive, or does this provide me some type of service? And there might be some gain there, and there might be some gain there because basically the biggest gain that you get is they go buy new computers, new technology, better things come out, and it automatically is available to you, especially if you're platform as a service. If you're using platform as a service, a new feature is available, like we're using Scribd, a document platform. Scribd adds features to their document storage and their document handling. We get that for free. We don't have to go do a new procurement. We don't have to go pay new money for it. So at the platform as a service, it's really great. We get the features. But the thing that's most interesting for me is the innovation, right? And it's the self-service of getting resources, that a developer inside of an agency who has an idea, a group of people that want to collaborate, can go to a web page and procure a server with a stack on it. Set something up, build a prototype, and show that prototype. That they could set up, that they could move data, they could do something, and they could suddenly set up 20 or 30 or 50 servers and run some data analytics or something like that without having to go through procurement, without having to talk to IT, without having to get permission to do that. People often talk about the internet as, that the internet means never having to ask, can you do something? And I think the nature of self-procurement of the cloud as a way for doing innovation is a tremendous advantage, and probably the biggest opportunity for government to find new efficiencies and productivity than it is if we're just talking about moving my mail server someplace.
I think Greg really hit a point here. So I think maybe a year or 2 years ago, when President Obama held that first online town hall meeting, that meeting is not held by WhiteHouse.gov, their own servers. It's actually held in the cloud, supported by Google's data center. So in that sense, the White House saves money, and they don't need to purchase another 100 machines for this event only. So they come up with this new idea, let's do it in the cloud. So they are able to have a really successful event just for that purpose.
And now I think, so I have certain security questions there which might change a little bit, because if I want an individual inside of the agency, even if it's on our own local area network, to be able to go to a web page and set up a server, I want that individual to have root access to that server. All right, now, how do I put that server in some type of box and control what that person is doing on that server? How do I monitor that? I mean, for me, that's what because I really want to give that person a lot of authority, and yet now I have a different type of security question, because who knows what they're going to download and put on that server? How do I monitor that? How do I take a look at, how do I keep an eye on that?
It goes back to the thing. You can do all that today. I mean, it's you have full control. So just to give you the levels again in terms of the stage of starting a server on Amazon, you have username and password to start a server, but you can augment that with a two-factor authentication from a third party. You get to that point, as a part of starting that server, we allow you to download a X.509 private certificate. We give you private, we keep the public part. If you don't want to use that, you can get it from RSA and VeriSign. So you keep control of that server access. And I talked about that firewall. When it is started, it is locked down. Even you cannot access it. You need that access to try to open that control port. And at that point, you have your server. Only you have access because you got the private certificate from some other company that we don't even know, right? So it's that level of security, and then whatever regular monitoring tools that you use to monitor that, you can use the same tools. I mean, there's, allow access to that port and run it like it's in your data center.
And we're beginning to learn how to do that.
Yeah, I mean, that's where many things are actually possible. I mean,
So before we go to the audience questions, I have one more question. And this question is based on the concept that we know eventually in the next, maybe 6 months, and this is Swami channeling right now, I'm doing my prediction. 6 months to a year, there's going to be a major system, it could be a major government system that ends up getting hacked. It gets hacked in the cloud. It's hacked, not that systems aren't getting hacked in the cloud right now, because of course they are, but a major system is going to get hacked in the cloud, and it's going to be all over the Washington Post, the New York Times, every major publication that the cloud has been hacked. But it's probably more than likely going to end up being an operating system wasn't configured correctly, and it was really up to the customer to configure it correctly, but the cloud is going to end up getting blamed. So as an industry, what does the cloud providers do? What do we do as customers to sort of insulate ourselves from mass chaos occurring when people perceive that the cloud is extremely insecure? Greg?
I'm just thinking about the BP oil spill. Yeah, I mean, I think that there actually was already a Drupal server or something. I think that something already got hacked, and it was kind of blown up a little bit as a kerfuffle, but it wasn't someone using platform as a service. It was I suppose it's going to happen. I suppose it's going to be a big news story. I suppose and then I think everyone is still going to continue to move forward. I mean, I guess I'm not. I look at the other kind of major disasters that happen in the world and accidents that happen, and I look at the other major things that people argue about whether they're risks or not risks, and we seem to move forward with them. So.
But you mentioned BP, and BP, when that oil spill occurred, all drilling stopped in the Gulf. So that's what the perspective is, a major scare can actually cease innovation for a period of time. Whether or not it stops it indefinitely, which I don't think it would, but I think you're right, things will go on. But
I suppose it's a good question to look further into. I mean, there was everyone is aware of what happened with the RSA tokens, I assume, right? So that was fairly significant. And so what happened? Well, there were some phone calls, there were some meetings, people changed their passwords. Yeah, I think I should have a serious face on this. It's a concern, and there will be actions that take place, and there will be some consequences when just like there's been consequences when anything bad happens. But I think that I don't think it's the major risk, to be quite honest.
Go ahead.
So I think during these events, there's two things that are important. The first is that you never lie or try to cover it up, because you will always get caught. The second thing is you should have a clear understanding and a definition of the roles and responsibilities related to security on both sides before the event. Because where these events get dragged out and where errors occur is if I'm going negotiating for transparency with my provider after the fact. That's too late, right? We need to understand in advance when there's an event, who does what to whom, when, and what data comes over the transom from whom to whom at what time. If we thought that through in advance, okay, we're going to come to resolution much more quickly, and we're going to have better answers for the press than if we think about it afterwards. And that's why it's really important, right? The incident response plan is a requirement for FISMA, right? And that's why it's important to never, ever absolve yourself of responsibility for security and assume it's the cloud provider.
Yeah, I mean, it's just interesting that you raised that. Just last night, I happened to hear that the perception or the polls are back to 69% on CNN. Said when the oil, incident happened, at the time it was 69. At the incident, it dropped to 49% as to how many people really want to, drill. Now it's back to 69%, right? So I mean, that's the nature, human nature. We can't change that. I mean, can we say, we'll never have incidents? Absolutely not, right? And same thing with airlines. They happen, and we are worried, and we can go back on the flight. I mean, it's the convenience versus, effectiveness and productivity, all that together. Kind of.
I just go off topic for maybe 1 second. So, when the oil spill happened, I was at FEMA, and they came to us and said, "What can you have up tomorrow?" They didn't say, "What can we have up a week from now, and how do we get hardware?" They said, "What can we have up tomorrow?" And it's very important that when we're talking about cloud and we're talking about paradigm shift, that you understand that the shift is from buying commodities and hardware and software to buying services, right? So now I am buying platforms that are available. I am buying a web server that is 99.99% available. I am buying a piece of software with a level of security that performs this for me. When that happens, right, I'm not just taking my legacy applications, moving them to the cloud and hope I save money. The concept is I go from spending 70% on infrastructure and infrastructure support to spending 30%. And either that 40% difference goes back into my budget, or I start to use it to focus on my mission. I start to use it to focus on innovation and servicing the citizen. And that's the promise of cloud, and that's why it's really exciting to be up here. And
yeah, I think, and I think I also, we're all very concerned about security. What's not going to keep me up at night is how somebody else does security. With respect to my information needs to be secure. If someone else has, if there's an error somewhere else, I don't think that is a reason for us to stop pursuing our course of action.
Actually, I wanted to, having said that, though, I mean, we are really a very customer-focused company, and if there are ideas, so like come back and say, hey, you said all these controls exist, but this is really something that I believe will help my security, and we want to hear your ideas and try to make it happen. Because, I mean, I run into conferences and people come and say, hey, posted something on the forum, and I can't believe it got addressed. So we are constantly listening to customers and responding to our customers' needs.
At this point, we're going to open up to questions from the audience. I think, Bhavesh, you have a question?
Well, thanks, the panel. It's been an excellent dialogue. One thing I would like to ask is, the question that we should be asking ourselves is not what's the biggest barrier to entry, and always by default I understand that trust is the biggest barrier, and I would propose a different answer probably. Trust is not the biggest barrier, right? Because as technical folks, as engineers, we always think of things as binary, and trust is never binary. It's not 0 and 1. So it's kind of somewhere in the middle. And how we get to that right place in the middle is transparency. And it's really having that dialogue, as Bill mentioned, which is what I see completely lacking. It's not that you guys are not doing as vendors or as customers, we don't know what to ask. But when you ask a simple question like, where is my data going to be located? You ask 5 cloud vendors and you'll get 5 gray colored answers and stuff like that. So we need some more black and white, discrete answers on those. I don't know how we can get to that stage, or if you guys have any thoughts on that. It's really, how do you make it transparent? Because everyone agrees it's innovation, it's cost benefit, it's all those good things, right?
I think that's a very good point, because I think the top issue that our security folks were concerned about was the hypervisor. Like, it was what are the controls on the hypervisor, and it was also, if we don't know where our applications are running, if we don't know where our virtual machines are running on, what happens if our 3 redundant virtual machines happen to be on the same piece of hardware? Like how do we know whether or not we all have, where those virtual machines are, and having a clear answer to that would be very helpful. And I would also say the related to that is the list of what the cloud was that Bill gave before. I thought was really good, and one of the items was measured service. But right now, everybody measures service differently. So if you if I'm trying to price different vendors and come up with a comparison so that I can do a procurement, everybody actually measure, there are different schemes of how they're measuring the service that I'm buying, which makes it very challenging for me to decide to figure out how to buy.
Can I just follow up on that?
One thing I just want to mention, we're running really short on time, so we have a chance to answer that question. We'll ask one more quick question, and then we'll get to the part that everybody's really stick around for, which is the iPad from GovernmentCIO.
So if you look at this from the point of view of the provider, right, unless I have common security requirements, that means that the provider needs to respond individually to every query from every agency, from every state, local, tribal, and commercial authority that wants an answer. So in order to reduce the burden and to get commonality, it's really important that we as an industry come to a common set of security requirements that we can consistently apply and interpret. And only then, I believe, are we going to get commercially viable visibility into these providers, because the security risk for them is too high. It's their secret sauce. If they get penetrated, I mean, what can I get from 10 cents an hour? What do I really expect? In how many hours is Amazon expected to spend on that?
I mean, so it goes both ways, right? If I give the ability to see where my hypervisor is, that could be used for a side channel attack by someone else, right? And we go down to, as I said, regions, availability zones. If you're starting a server, you pick where your availability zone is, and you pick where your region is, where your data is. I mean, how much more? I guess I'm missing the transparency aspect of it, because we try to be as much transparent as possible with everything, including our pricing, is just right open, right?
So it begs the question about standards, and I think that right now we're in it begs the question about standards a little bit, and I think right now we're in the wild, wild west area of cloud computing. And so how do you feel about standards? Are you guys in a we'll be first past the post and we'll dictate the standard, or is there going to be some body that generates this so that when we come around to have to implement all of these things, we'll all be able to rely on the same thing?
It's a classic debate again, right? So you have efficiencies and effectiveness. Standards drive efficiencies. Effectiveness is driven by innovation. We talked about innovation so much. I mean, when you are driving innovation, it's hard to ask for standards in innovation, because it's going to take to standardize those innovations to, or to gain efficiency. So
that's why FedRAMP has been struggling it's a very difficult concept at first to set up a standard set of controls that all infrastructure providers will adhere to.
Real quick, NIST has 5 working groups. So security, one called SAGAC, which is Standards Acceleration, a Standards Working Group, Taxonomy and Reference Architecture, and a Use Cases Working Group. So their first release, this is all available on Twiki and publicly available. So if you want to go look at the work that's being done or join into that conversation, we'd love to have you.
We are having a NIST security working group meeting with the CSA group on Friday, in fact, as we speak. So that dialogue is going on. It's just trying to come to the middle point.
All right, guys. Any other quick questions?
Just one quick
RH, I'm sorry.
My really quick comment is that mission trumps. The mission is going to trump everything else, right? And it's the imperative on us to make sure that we provide the mission capabilities, or they will be provided for you. And you have a whole entire group of individuals who are flooding into the market who are used to already using cloud-based capabilities. And whether it is the warfighter in Iraq that is connecting up to local ISPs and using Facebook to coordinate platoon-level activities, which has happened.
Absolutely.
Because the DoD did not provide the capabilities that they needed and the comms that they needed in the field, but a local ISP provider was providing that. it's going to happen. So it's up to us to decide to provide that capability and quickly enough and in a controlled manner, or you will lose all control. Right, so it's not a matter of is it going to come. It's are we going to be able to push it fast enough so that it doesn't come without any control.
Okay, with that said, we are going to have Lily and Bill come up front and help me with conducting this raffle. Oh, we lost a couple of cards, and those would be the most angry people. Oh, they're blank ones. Okay. Oh, come on up front, right to the center of the room, guys. So. Transparency, so that everybody can see. Well, wait, hold on a second. We'll let Howie, since he's a professor and he has absolutely no.
My name is there.
Oh, your name's in there. Oh, okay. Whose name is not in it? Leah. Okay. Shuffle it. You can shuffle it up, and then Lily, after she's shuffled up, then you can grab one out. Who's going to win the iPad 2 from GovernmentCIO, the best company in the world? Alan Penn, come on down. Come on down. Come up front. Congratulations, Alan.
Thank you, Lily.
And that concludes today's workshop. Unfortunately, I know you guys probably have other questions, but we're running a little bit long, and Leah will kick my tail if I let this drag out any longer. Anybody have any questions, stop by, hand me your card, ask me the questions on the way out. I'll get back to you. My email address is bmoran@governmentcio.com. That's BMORAN at governmentcio.com. And Ernie, I was going to try to include private cloud stuff, and I was going to try to bring in the HP angle, but I didn't get a chance. I'm sorry. We will be doing another one very soon. All right, guys, take care.
It was good meeting you too. I don't